In this example, we have simple gear train B, which we have a large gear going to a small gear. This gear would be our drive gear, our input gear, because we have a crank attached to it. This would be our output or driven gear. When we turn our crank, we are turning the left gear, powering the left gear, which then turns the right gear. Notice that the travel of the gears is opposite of one another. Both are rotary motion, so the input and output are both rotary. We are increasing the speed on this build because the crank is on the large gear. It's forcing the small gear to travel faster because of the size of the gear. So this gear, since it's smaller, it has to travel faster to keep up with this gear because of the number of teeth on the gear. Now if we change where the input is, now we are turning the small gear, and that is now our input gear, which transfers the energy over to the large gear, which the large gear is going to travel slower than the small gear. Now we are creating more torque or power. So by going from a small gear to a large gear, you create more power. This mechanism, its drive shafts are both parallel to one another. The flow of power is reversible because we can turn either gear and it will turn the other. And by turning the gears left or right, we're able to turn the other gear the opposite direction. So the direction of travel is also reversible.